Greetings, students. Today we're going to discuss practice test 3-3. Let's begin. Question 1. Solve the proportion. I realize here that on this proportion 10 divides evenly by 5. However, on the test this might not divide evenly. So I'm going to do the way you might need to work this on the test, which is diagonal multiplication or cross multiplication. So I'm going to take 5 and I'm going to times it by x. I'm going to take 8, I'm going to times it by 10. And then divide 5 into 80 to get the answer here of 16. Now again, this because of the way this was set up, the original question, it did divide evenly on the right here, 10/5. And so that would have made it 2, and I could have taken 8 times 2 to get the finished answer here, which would have been 16 as well. That may or may not happen on the test, however. If it does happen on the test, you're welcome to do the work that way. Question 2. And this one we do have to do the work properly because it is set up in such a way where, as you can see, it doesn't divide evenly right now. So we're going to have to do 4 times n, which is 4n, and then 3 times n plus 7, or 3 times the quantity n plus 7, more appropriately said. So 3 times the quantity n plus 7 would be 3n plus 21. Subtracting 3n from 4n is going to yield a single value of n. So my n here is equal to 21. I can check my work here, and it's going to be similar on the test as well, where you can check your work. 21 divided by 3 is 7, and 21 plus 7, which is 28, divided by 4 is also 7. It will be possible for you to check your work on the test with this question as well, if you so want to. Next question. Ratios between similar shapes. So here I've got the small shape with x minus 4 and the 7. So when I set up my ratio here, I'm going to have an x minus 4 and a 7. I like to put them on the same spots on the top in the numerator there, because x minus 4 is on the same shape as the 7 there. Now the reason I'm not using the 8 on this particular diagram is because the 8 is the longest side of the triangle, and it should relate to the longest side on the other triangle, which is not labeled in this particular diagram. So in other words, the 8 is not used here because it's not labeled on the other particular diagram. Anyways, underneath the x minus 4, I'm going to put the side that x minus 4 relates with on the other triangle. So x minus 4 relates with this 20 because they're both the shortest sides of the triangles. So I'll put the 20 here, and I'll put the 35 here. And now, it is useful on the test here to reduce before you cross multiply. 7 divided by 35 does make 1/5. If I don't reduce here, I'm going to have to multiply the 35 by the 4, which will be somewhat lengthy in terms of the amount of work required. It is acceptable. It's something you can do. It's just somewhat lengthy. So I will divide 7 by 35 here and make 1/5, and then I'll cross multiply or diagonal multiplication. So 5 times x minus 4 is going to be 5x minus 20, because 5 times the quantity x minus 4. So 5x minus 20. And then 20 times 1 is going to also be 20. Adding 20 to 20 is going to yield 40. And then 40 divided by 5 is going to yield the value of 8, my answer. So I can again check the answer here if I so desire to. As you can see on this particular triangle, 35 is 5 times as big as 7. In other words, this first shape has a scale factor of 5 compared to the second shape, 5 to 1. So the answer here for this length here should be a 4. That's why x has to be 8, because 8 minus 4 is 4. So 20 is 5 times as big as 4, in other words. And question 4 here, we're looking at the scale factor. So I'm going to relate the sides together that go together. The sides that go together are the sides that are in the same locations. So 12 goes with the 4 here. So I'm going to say the scale factor here is 12 to 4, which is the same as the scale factor of 3 to 1. And I don't have that option here, but I do have the option of 1 to 3, which is the same option, just reversed order. When I'm saying a scale factor of 1 to 3, it means that means one of the shapes is 3 times as big as the other one. So the smaller shape is a third of the larger shape, in other words. That's what I'm saying here. Alright, question 5. So here I'm asking for the missing length here with this question mark. You can call it x if you want, or leave it as a question mark. So x, there's two ways to set up this ratio. I like to set up x with the 39 because it's a partial length. Both of those are partial lengths. X is a partial length and so is 39. And then I like to set up the full lengths together, the 24 and the 52. It is, however, possible and acceptable to switch the 24 and the 39 here, the locations diagonally, as we've discussed in class. Now once again, here it is going to be useful to reduce this into a third. A third? No, not a third. It would divide evenly by 4 though. It's going to be useful to reduce this before I cross multiply, otherwise I'm going to have to end up multiplying the 39 by the 24, and it's going to be somewhat lengthy, my work. So I'm going to divide these by 4 and reduce this ratio so that it's not quite as large. So my cross multiplication will be somewhat easier. So 24 divided by 4 is 6. And 52 divided by 4 is 13. Now I can do the cross multiplication and get my answer. 13 times x is equal to 39 times 6. Now notice I left the 39 here separate from the 6. I'm strategically doing this because I know 39 divides evenly by 13. So it may be useful on your test as well to think about, do these numbers divide evenly? Because if they do, it will reduce the amount of work you have to do with your multiplication steps, because I know 13 will go into 39 here. So when I divide by 13 here, I can take this 13 into 39, make it into a 3, and save myself some effort to get in the x equals 18 here. My value, in other words. 3 times 6, 18. Once again, it is possible to check your work. So I can check my work with my ratios here. This should be a 6/13 ratio. So if I use 18 here to 39, it should end up reducing into a 6/13 ratio. The same ratio as 24 to 52. So 18 to 39, those are going to both divide by 3 evenly. It'll be 6 and it'll be 13. Alright, next question. Here I've got a full length. I'm going to take this full length and put it with the other full length, x over 54. And then I've got a whole bunch of other options here. I've got a 7, I've got a 6, I've got 11, and I've got a 99. I've got a whole bunch of other options here for me to set up this particular ratio. I would use the 7 with the 6 here, setting this ratio up. 7 and 6. And then once again we can diagonally multiply to get our proper values. Now here I'm looking at this 6 and this 54, and I know those divide evenly. So rather than multiplying the 54 by the 7, I am going to take and I'm going to write it separately, and then I'm going to divide it here to save myself some effort in the problem. Because I know that'll go in 54 divides by 6 9 times evenly. So x here should equal 63, 9 times 7. So you will need to use some strategic division with these questions so that you can get save yourself some effort as you're doing the cross or diagonal multiplication. Alright, next questions. The triangles need to pair similar. So HG, which is 20, should go with HV, which is x minus 1. So I'm going to start off with HV and HG. X minus 1 over 20. And it's listed right here, HV and HG. The other length here that's labeled is the WH, or the HW. And it should go with the HF. So I'll put that as the other ratio, 13 over 26. Now this will divide and make a half. So I'm going to reduce this before I do my diagonal multiplication again. Just again to save me some effort, so I don't have to do a whole bunch of work. I'm going to take the 2 times the x, and then the 2 times the minus 1. So 2 times the quantity x minus 1 is 2x minus 2. And then 20 times 1 is 20. Adding 2 to 20 will yield 22. And then x should be 11 here. Once again, it's possible to check your work by putting the 11 back in. So 26 is twice as long as 13. So this should be half as long as 20. 11 minus 1 is 10. Half as long as 20. Same deal here. ML, though, should go with VU. So make sure you set up the proper items together. ML and VU. So it should be 3x plus 1 over 26. And again, I like to put the same triangle in the top. So 3x minus plus 1 and the 9 on the top over here. It is possible to set it up the other way around. That's just the way I'd like to do it, with the 18 underneath it. Again, that 9/18 is a half, so it's going to be useful for you to make that into a half before you diagonally multiply to save yourself some effort. So taking 2 times the quantity x plus 1 will yield a 6x plus 2 equals 26. Subtracting 2 from 26 yields 24, and dividing 24 by 6 yields 4. Once again, it's possible to check your work here. 18, when I double it, when I half it, not double it, it becomes 9. So this should be half of 26, which is 13. And 3 times 4 is 12, plus 1 is 13. Question 9, geometric mean. The geometric mean, again, is the multiplicative mean. So there's 2 ways to look at this. Multiply and then square root. Or you can think of it as figure out what you need to multiply by twice to get the finished from the start to the ending number. So I'll do the multiply then take the square root route. 5 times 45 is 5 times 40, which is 200, and then plus 5 times 5, which is 25. So that's square root of 225, or 15, as my finished answer. I also could have looked this again with the other root by thinking to myself, well, 5 times 2 would be 10, and then 10 times 2 would be 20. So 10 would be the geometric mean of 5 and 20, because 5 times 2 is 10, and 10 times 2 is 20. And then 5 times 3 is 15, and then 15 times 3 is 45. So that's the proper geometric mean, because 5 times 3 is 15. 15 times 3 is 45. The proper multiplicative mean, and if it was 5 times 4, it would be 20. And then 20 times 4 would be 80. So if it was 5 and 80, the multiplicative mean there would be 20. And then if it's 5 times 5 would be 25. Times another 5 would be 125. Multiplicative mean of 5 and 125 would be 25. And it just keeps going up. 5 times 6 is 30. 30 times 6 is 180. 5 and 180, multiplicative mean is 30. Alright, next item. 27 is the geometric mean of 9 and what number? So again, I'm looking for a number that's multiplied to get 27. So I'm going to actually work this a little backwards from what the normal way would be. So normally you would square the 27, and then you divide by the 81 here. But I'm going to think of it this way. Again, 27 is the multiplicative mean. So I'm asking myself, what do I have to multiply 9 by to get 27? Well, 9 times 2 is 18. 9 times 3 would yield 27. And then once I figure out what I have to multiply by to get 27, I'm going to take 27 and multiply by that same number to get the ending number. So 27 by 3 would be 60 plus 80 plus 21, which would be 81. So 27 is the multiplicative or geometric mean of 9 and 81. Because if you take 9 times 3, you get 27. If you take 27 times 3, you get 81. So on the test, next class, you may need to work the problem this way. It is, however, smaller in nature, the problem, so you can square the number somewhat easier on the test tomorrow. And again, to do this with the squared, you would take 27 squared, and then you would divide by that number there, by that 9, so to get your to get your other number. Anyways, you do have options on the test tomorrow with a root here, or with a squared, I should say, instead of with a pattern. Question 11. State if the triangles are similar. I'm asking if the ratio between the sides is the same. So I'm looking at the 3 side ratios here. It's all 3 sides are labeled Remember that if not all three sides are labeled, then the angles might be labeled, or maybe the two angles or two sides and an angle will be labeled, something like that. So depending on what you're given here, you might have a slightly different setup showing that the triangles are similar or are not similar. So I'm going to start off by figuring out if they are in fact similar by relating the sides together. So the smaller triangle has sides of 35, 65, and 70. Again, I'm asking if it's similar. I'm not stating it's similar, so I'm going to put a question mark above this equal sign. The larger triangle has sides of 56, 104, and 112. Again, the order matters here because the smallest side should go together, then the next largest size, and then the longest side should go together. And I'm going to think about, do these ratios make the same ratio, each particular one of these ratios? So 35 and 54, well, that would divide evenly by 7. By 7? Oh, it's 56, not 54. It should divide evenly by 7. It's 56, not 54. And it divides evenly by 7. She's in the room over next, across from Fish. That portable. Yeah, on the end, yeah. Yeah. See you, boss. So we divide the 35 and the 56 by 7, and we get 5 over 8. And then the 65 and the 104, now those are going to have a common factor as well. So we're thinking here, you know, how would I get 5 from 65 perhaps? We're thinking along those lines. And when we get 5 from 65, we'd have to divide it by 13. And does 13 go into 104 8 times? Yeah, well, 13 times 8, 24 plus 80, yeah. So I divided that first fraction by 7. The second one I'm dividing by 13, which it makes 5/8 as well. And this last one here, again, to get 5 out of that, I'm going to have to divide that one by 14. Sorry, I had to put some extra marks there. And 14 times 5 would be 70. And does 14 go evenly into 112 8 times? Well, 14 times 8 would be 80 plus 32 would be 112, yeah. So these are in fact similar triangles. So now I can write out the similarity statement. Triangle PQR is similar in nature. It's 5/8, the ratio here in nature, to triangle P. And the next side would be, well, Q would go with F. F, E. So when you're looking at this, you're determining if the sides have the same ratio. Now, if they don't have the same ratio, the triangles aren't similar, so you have to put the answer no if it wasn't the same ratio. All right, number 12. This is an easier question because both these angles are marked the same. The third angle must be the same by the triangle sum theorem. So this is congruent by triangle sum. So therefore, these triangles must be similar in size. So D goes with R, E goes with S, and F goes with T. Alright, so up here at the instructions at the top I said, state if each pair is similar. That's what we did here. If so, state how you know they're similar by triangle sum theorem, by congruence between the sides, and then complete the similarity statements. Alright, next thing. Going to plot V at 2, -4. 2, 1, 2, 3, 4, -4. W at 3, -1. So here's V, here's W. X at 3, -2. Here's X. And Y at 5, -5. Next thing we're going to do is rotate 180 about the origin. So again, we're just going to spin the paper around. We're going to plot the same points again. But now they're going to be in the second, instead of in the fourth, in the second quadrant. So we're now at 2, -4 for V. So this is still V, it's just 2, -4. It's just now in the second quadrant. We're still at 3, -1, and 3, -2, and we're still at 5, -5. I'll go back to the original orientation and I'll label the points. So here's the image of V. Here's the image of W. Here's the image of X. And here's the image of Y. Again, 180 rotation would be a half turn. If it was 90 clockwise, it would put it in quadrant 1. 90 counterclockwise would be in quadrant 3. Alright, find the coordinates of the vertices if I move them left 2 and then up 2. That's what this is saying to do. So I take each point, move them left 2 and up 2. So left 2, up 2. So there's the image of J. Left 2, up 2. There's the image of K. Left 2, up 2. There's the image of L. So there's the image of triangle JKL. Alright, write a vector that describes the transformation. So here I'm asking what happened between the points. So how far left and right it went, how far left or right it went, and then how far up or down it went. So I'm looking at my x values here first. The x values increased by 5. And they did that consistently with all 3 points. 3 plus 5 is 8, -2 plus 5 is 3, -3 plus 5 is 2. So I'm going to write this vector as the vector, or the translation, 5, because x is increasing by 5. Now if it was decreasing by 5, this would be a -5. So if I switch the order of these x's and y's here, then it will be a -5 if I switch the order of these x's and y's, these points. Then the y value here is increasing by 7. -3 plus 7 is 4. 1 plus 7 is 8. -1 plus 7 is 6. So this will be 5, 7. More specifically, the vector 5, 7, or x becomes x plus 5 and y becomes y plus 7. We're increasing x by 5 and we're increasing y by 7. Right 5 and up 7. Alright, question 16. I'm going to work this question in pencil, because as we're plotting the points, we're going to want to start erasing our images if we want to have the proper notation to it. It's very difficult to have all the points plotted with this one. So A is at -3, 4. 1, 2, 3. 1, 2, 3, 4. There's A at the coordinate -3, 4. What I'm going to do with A is I'm going to reflect it in the line x equals 1. I'm going to do that part first. So I'm just going to work with point A right now. So I'm going to reflect it in the line x equals 1. So right now A is 1, 2, 3, 4 to the left of the line of reflection. Its image will be 4 to the right. 1, 2, 3, 4. So its image will be at 5, 4. The original was at -3, 4. Its image is at 5, 4 after a reflection across the line or on the line x equals 1. Now that's just the reflection part of the question. Now I've got to do the translation. So now I'm going to move the y value up by 2, which is going to put A at 5, 6. The second image of A. And the final thing I'm going to do here is rotate it 180 about the origin, which is going to put it all the way down into quadrant 3 at the same coordinate value at 5, 6 in quadrant 3, except it's going to be in quadrant 3 value. So I'm going to spin the paper around. It's going to be at 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There's my finished answer for the image of A. So it's at -5, -6. Alright, working with point B. Now again, it might be useful to erase these intermediate points after you get the finished answer for A, as it can be difficult to look at all the points together. So that's what I'm going to do. That's why I was working in pencil. So I can erase A now and just work with B so that it doesn't confuse me as much. B is at 1 comma 4, which is lucky because B is on the line of reflection. B is exactly on the line of reflection here. So when I reflect in the line x equals 1, well, x is already 1, so it doesn't go anywhere. I'm going to add 2 to the y value for the next part. And then I'm going to rotate 180 about the origin. So it's in quadrant 1, it's going to end up again in quadrant 3. And it's going to end up in the same value at 1 comma 6. Except it's the quadrant 3 value for 1 comma 6. So it's at 1 comma 6, just in the quadrant 3 value. So there's the finished value of B, or the finished transformation for B, which is at negative 1, negative 6. C is at negative 1, 0. And again, I might erase the B points here before I move on and do C, but they're not really in the way, so I'll keep them where they're at. So here is C, negative 1 comma 0. When it reflects in the line x equals 1, it's 2 to the left, so it'll go 2 to the right. It'll be at 3 comma 0 now. I'm going to move up 2, and it's going to be at 3 comma 2. And then I'm going to rotate 180 about the origin. It's going to put that in quadrant 3. So it's going to have the same value, 3 comma 2. It's just going to be the quadrant 3 value of it. So again, I'll go in the quadrant 3 here, and I'll 1, 2, 3, comma 2. There's going to be the finished image of C. Or the finished transformation for C at negative 3, negative 2. Anyway, I hope this helped. If you want to, you can come in after school Thursday, and I'll be here for a little bit. Make sure you come out after, though, because I'm going to be going home. Anyways, good luck on your tests.